Hi, welcome back to my channel. This is E. Manjula, lecturer in Electrical and Electronics Engineering, Government Institute of Electronics. So, in the last sessions, till the last sessions, we have discussed about the DC circuits. Okay, so from this session, we will discuss about the AC circuits. Okay, so in this session, we are going to learn about the definitions which are going to be used in AC circuits, mostly the terms. So we will see their definitions and the problems also. Okay. So yes, in the previous sessions we discussed about the DC circuits and the working of a simple loop generator also. So today's objectives is that the definition of an alternating quantity, and that instantaneous value, maximum value, frequency, time period, average value, RMS value, and form factor, peak factor. Okay, so these are the some of the definitions we are going to see, and these are the terms which are mostly used in alternating quantities. So what is instantaneous value? Here we could able to observe the waveform, which is a sine wave. This is a sine wave from 0 to 360 degrees, and the magnitude, so the instantaneous value is that. So here the instantaneous value is the magnitude of an alternating quantity at any instant is known as the instantaneous value of an alternating quantity. Okay, so the magnitude of at any instant is called instantaneous value. Okay, maximum value or amplitude, it is also known as amplitude. Okay, so we will see what is maximum value. The maximum value of positive or negative of an alternating quantity is called the amplitude or peak value. So the maximum value here and here, this is a positive maximum value, and here it is a negative maximum value. Okay, which is also called as amplitude. Frequency. So frequency is denoted by F. So what is frequency? Frequency is that the number of cycles completed by an alternating quantity in 1 second is called the frequency. So frequency F is equals to 1 by T, and the units of frequency is cycles per second or hertz. What is a time period? Okay, time period is denoted by capital T, and time taken by an alternating quantity to complete one cycle is called the time period. So the time period T is equals to 1 by F, vice versa. Okay, F is equals to 1 by T and T is equals to 1 by F. And the units is seconds. Next, average value. What is an average value? We'll see. Okay, it is defined as the steady current or DC current which, when flowing through a given circuit for a given time, produces the same amount of charge as produced by an alternating current when flowing through the same circuit for the same time. Okay, so the average value is that when a DC current is flowing through a circuit for a certain time, it will produce the amount of charge as same that when an alternating quantity is flowing through the same circuit for the same time. Okay. And RMS, that is root mean square value. What is a root mean square value? So here it is defined as the steady or DC current which when flowing through given circuit for a given time produces the same amount of heat as produced by an alternating current when flowing through the same circuit for the same time. Okay. So here the same produced as heat, and in average it is a same amount of charge. Okay. So the time for both DC, when DC is produced in the same circuit, and the AC, the timing is same and the circuit is same, and producing the heat here it is same. Okay. So that is called root mean square value. It is also known as, or else also called as, effective or virtual value. Next is form factor. Okay. It is the ratio of average value to, RMS value to average value of an alternating quantity. So, form factor is equals to RMS by average value. Okay. The next is the peak factor. It is the ratio of maximum value to the RMS value of an alternating quantity. So, we have gone through the maximum value, that is amplitude. Okay. So, maximum value divided by RMS value is a peak value, peak factor. Fine. We will see some problem and the definitions what we have discussed before. We will check out how it is going to find out the solution or the output. Okay. The maximum values of an alternating voltage and current are 400 volts and 20 amps respectively. In a circuit connected to 50 Hz supply, and these quantities are sinusoidal, the instantaneous value of a voltage and current are 283 and 10 amps respectively at t is equals to 0. Both are increasing positively. Okay. Write the expression for voltage and current at times. So we have to write the expression. So here instantaneous voltage value V is equals to 283 volts and V maximum is equals to 400 volts, I maximum is equals to 20 amps. So the general form of sinusoidal voltage equation is V is equals to V maximum sine omega t plus theta. Okay. So V is equals to 283, V maximum is equals to 400, sine of 0 plus theta, that is sine theta is equals to 283 by 400, sine pi, sorry. Okay. So pi is equals to 45 degrees, which is equals to pi by 4 radians. Hence, V is equals to 400 sine of 100 pi t plus pi by 4 volts. Okay. So this is a voltage form. Similarly, we have to find out even current. So current equation I is equals to I maximum sine omega t plus pi at t is equals to 0. So I is 10, I maximum is 20, sine of omega 0, t is equals to 0, and pi we don't know. So we are going to find out the pi. So sine pi is equals to 10 by 20. So therefore pi is equals to 60, which is in radians, pi by 6 radians. So here the current equation will become I is equals to 20 sine of 100 pi t plus pi by 6. Okay, how you are getting this 100? 2 pi ft, right? So 2 into f, that is 2 into 50 is 100. Okay. Okay. We will go to the next problem. So here, an alternating current of frequency 60 Hz has a maximum value of 120 amps. Write down the equation for its instantaneous value, reckoning time from the instant the current is 0 and is become positive. Find the instantaneous value after 1 by 360 seconds. Okay. And the time taken to reach 96 amps for the first time. So the given data is F is equals to 60 Hertz, I maximum is equals to 120 amps, instantaneous value I is equals to 120 into sine of 2 pi ft, which is equals to 120 sine of 2 pi into 60 into t, but t is equals to 1 by 360 seconds. So I is equals to 120 sine of 120 into 180 into 1 by 360, which is equals to 120 sine of 60 degrees. So hence I is equals to 103.9 amps. That is the instantaneous value at t is equals to 1 by 360 seconds. Now we have to find out what is the time at 96 degrees, at 96 amps. So here F is equals to 60 Hertz, I is equals to 96 amps, I maximum is equals to 120 amps, I is equals to I maximum sine omega t pi. In general form, pi is 0. Hence, 96 is equals to 120 sine of omega t. So, we have to find out what is t. So, sine of omega t is equals to 96 by 120. So, omega t is equals to 53 degrees. But we have to find out t. So, t is equals to degree divided by 2 pi f. So, we know that omega is equals to 2 pi f. Okay. So, we know f is equals to 60. So, here this is t. Okay. So, t is equals to theta divided by 2 pi f. That is, here they took omega t is equals to 53 degrees, so which is equal to theta. So, t is equals to 53 into 360 into 60. F is 60, 2 pi is 360. So, which is equals to 0.00245 seconds. So, that is the time taken to get 96 amps. So where we are getting 96 amps at t is equals to 0.00245 seconds. At that time we are achieving the instantaneous value I is equals to 96 amps. So in this session we have discussed about the definitions related with alternating current and some problems where this definitions have been involved. Okay, so we will see some quiz points. What is the maximum value of a voltage? Maximum value of a voltage in the equation of an instantaneous voltage. Here, V is equals to 450 sine of 314t plus pi by 4. So here, this is V maximum. So 450 volts is a V maximum. The next quiz point is, what is the frequency in the equation? So here V is equals to 450 sine of 314t plus pi by 4. Okay. So asking for frequency. So 314 is nothing but this is omega. Omega is equals to 2 pi f. So here we have to solve it. Okay. So 2 pi f is equals to 314. So f is equals to 314 divided by 2 pi. Then you will get 50 hertz. Okay. So it is 50 hertz. And what is the unit of frequency? The units of frequency is cycle per second and hertz, both B and C. So hope today's session that the definitions of alternating quantity, some of the important definitions of an alternating quantity we have covered, and I hope that it is understood to you all, and where we are applying and how we are using that alternating that definitions. And I mean that important alternating quantity terms also we have discussed it. Okay, uh, fine. So we will meet in the next session. Thank you so much.